Okay, so we were, I think we had finished work energy, right? Instantaneous axis of rotation. हाँ, मैंने एक क्वेश्चन दिया था, किसी ने मेरे को कोई एक भी कोई नहीं है जिसने मुझे सॉल्यूशन भेजा। हाँ, but to be fair, it is a tough question. So let me show you how it is done. Like I said, it is going to involve everything that we have learned up till now. So nothing will remain untouched. So we have the ladder sliding down, and let at this moment this be angle theta, this be y, and let this be x. So we know that tan theta will be equal to y, or y will be equal to x tan theta. Now, another relation that we can have here is x square plus y square is equal to L square, right? So the length of the ladder always remains the same. Therefore, the hypotenuse of the right angle triangle always remains the same. However, apart from the hypotenuse, nothing else remains the same. Side, the base, the angles, everything is changing with time. So if I differentiate this, I'll get 2x dx by dt plus 2y dy by dt is equal to 0. And this will tell me that dy by dt, I don't want to write dy by dt, so I will write dx by dt is equal to y by x into dy by dt. So this is Vx, this is tan theta, this is Vy. Now what is Vx and Vy?
minus y by x.
हाँ, मेरे को माइनस की एक्चुअली जरूरत है नहीं यहाँ पे. क्यों? Why? What do you think the minus is signifying? What is
Opposite
the meaning of
direction?
opposite? हम नहीं बोल सकते हैं because ये दोनों velocities different axes के along.
Y is decreasing, x is increasing.
Yes. इसका सिंपल सा मतलब ये है कि y जो है वो decrease हो रहा है and x is increasing. That is the only meaning of negative sign, right? You can never say that north is the opposite of west. It is a meaningless statement. North is the opposite of south, of course, yes. South is the opposite of north, of course, yes. East is the opposite of west, yes. East is the opposite of south, meaningless. So since the two velocities are along two mutually perpendicular axes, the statement that they will be opposite does not hold. Okay, so the minus sign simply tells me that y kam ho raha hai, x badh raha hai. That's why I have not written it. So one of the more common ways to confuse you in this question is to say that, look, tan theta is equal to Vx by Vy. And you can write it the other way around. You can write it like cot theta is equal to Vy by Vx. And then I can say that as theta approaches 0, what can you tell me about Vy? as theta approaches 0, what can you tell me about Vy? What can you tell me about Vx? And a paradox will be created that Vx will be
सर
going
बट
towards.
उस पॉइंट पे मतलब उससे जस्ट पहले कांटेक्ट छोड़ देगा ना.
Yes, very good. तो ये एक possible source of confusion क्रिएट होने का एक तरीका है, करने का तरीका है, but the answer is absolutely right. Theta will never approach 0, right? And that is what I actually wanted you to find. At what theta will it leave contact with the vertical surface? It will. This condition that I have written, this condition that I have written will never arise. It will never arise. Okay, so I'm just going to rub this out. I don't need this anymore. So we need to find the angle theta at which the object will leave the vertical surface, right? Now, from our discussions that we have had, leave the vertical surface का मतलब क्या होएगा? Ultimately हमें तो maths use करना है, तो leave the vertical surface का मतलब क्या होगा? हाँ, बिल्कुल सही, absolutely. So the vertical surface is left by the ladder would imply simply that normal reaction has become 0. There is, tell me what, there is another way of saying this wall will be 0. Can you tell me what that would be in this case for the ladder? Remember, there is no friction anywhere. Can you tell me what will be the n is equal to 0? इसका क्या मतलब क्या है? इसका consequence क्या होएगा? n is equal to 0.
सर टॉक अबाउट सेंटर ऑफ मास 0 हो जाएगा.
नहीं, एक्चुअली नहीं होएगा. टॉर्क अबाउट सेंटर ऑफ मास 0 नहीं होएगा, क्योंकि जो हॉरिजॉन्टल फ्लोर है उसका नॉर्मल रिएक्शन तो रहेगा ही ना.
ओके, हाँ.
So normal reaction because, okay, so to help you, let me draw the FBD of the object. So the forces acting on this are N, N1, mg. Right now, can you tell me what is so special about N? What is
Vx
so
will
special
become
about
constant.
N? Very good. Yes. Yes. Very good. Yes. So this would mean that AX is equal to 0. This would mean that Vx is equal to constant. Vx of what? हाँ, exactly यार. हाँ, यही मैं भी बोल रहा हूँ. Vx of what? Vx of what? Vx of rod. That would be an incomplete statement. Vx of what? Vx of the
सर आपकी वॉइस शायद
Vx
लैग हो
of
रही है.
हाँ सर,
what?
वॉइस लैग.
आपके लैग हो रही है.
Very good. Yes. सर गड़बड़ है, मैं नेटवर्क चेंज कर रहा हूँ. Let me see if I can get better. आ गया. हाँ, now is it better?
सही है.
Yes, sir.
Okay. So Vx of the center of mass. हाँ, बिल्कुल सही. Vx of center of mass. हाँ.
सर आप n is equal to 0 के बाद वापस बोलोगे क्या? मुझे सुनाई नहीं दिया कुछ भी.
N is equal to 0. N is the only horizontal force acting on the rod, right? If n is the only horizontal force acting on the rod, then when it becomes 0, the acceleration along x-axis of the center of mass must become 0, which means that the velocity along x-axis of the center of mass must become constant.
समझ गए.
आया ना समझ में? हाँ, मतलब वही है, F is equal to ma का वो है. So if this is the meaning of leaves the vertical surface, then surely if I can figure out ax as a function of theta, okay, and I just put it equal to 0, that should give me the answer. Or if I can figure out Vx as a function of theta, and if I differentiate it with respect to time, that should give me 0, right? And maybe I can figure out theta from there. So the purpose of the exercise, the purpose of the question now becomes finding the value of ax as a function of theta or Vx as a function of theta. Right? So first we'll try to find ax as a function of theta, and then we'll try to find Vx as a function of theta. Okay? अब ax कैसे निकालें और
फिर ax के लिए डिफरेंशिएट कर देंगे vx इक्वल टू tan थीटा vy.
नहीं
और-
गड़बड़ हो जाएगा ना गड़बड़ हो जाएगा. क्यों गड़बड़ होएगा? Anybody can tell me? I cannot differentiate this to get ax. Why? ऐसा क्यों है? Because I would be getting another term, that is d theta by dt. हाँ, vy भी आ जाएगा, dvy भी आ जाएगा, d theta by dt भी आ जाएगा. तो वो थोड़ा सा messed up हो जाएगा. No, let's find ax, because we are trying to find ax of center of mass. Let's find ax of center of mass using the normal methods, using the normal force. कैसा मोशन हो रहा है लैडर का? कैसा मोशन हो रहा है लैडर का? What is the motion of the ladder? बताओ भाई, कैसा मोशन हो रहा है लैडर का? तीन ही ऑप्शन है ना, रोटेशन, ट्रांसलेशन और रोटेशन प्लस ट्रांसलेशन.
रोटेशन प्लस ट्रांसलेशन.
रोटेशन.
रोटेशन प्लस ट्रांसलेशन हो रहा है ना, क्योंकि वो रोटेट भी कर रहा है, ट्रांसलेट भी कर रहा है. Okay, so let's write down then for the translation of the object. Right? नहीं, यहाँ पे integration हम see integration वगैरह, that should be the last resort when you are absolutely sure. नहीं तो यहाँ पे हमसे सीधा ax मांगा जा रहा है, forces हमने draw कर दिए हैं, तो first let's try from that. So for translation, I will get n is equal to max this is along the x-axis, of course, and I will get mg minus n1 is equal to may. Okay, ax and ay, of course, are the acceleration of the center of mass, ax, ay. Apart from this, of course, I have to talk about the rotation of the thing. So for rotation, okay, now I have this simple rule that we have discussed, that we will take the center of mass of the object as the origin, right? So this is one way of doing the question. I will repeat this question by using the concept of instantaneous axis of rotation as well. And I'll repeat this question using work power energy as well. So for rotation, we will get what? So it is going to rotate, it is rotating anti-clockwise. So the
सर
torque,
n1 into सर n और n1 के इंटरसेक्शन पे नहीं कर सकते?
हाँ बाद में करेंगे ना, अभी हम सेंटर ऑफ मास से कर
ओके
n1 into L by 2 cosine theta minus n into L by 2 sine theta is equal to ml square by 12 alpha. Right now, how many equations are there and how many unknowns are there? Let's check quickly. The unknowns that we have with us are 1, 2, 3, 4, 5. 5 unknowns are there, right? N, Ax, N1, Ay, and finally alpha. Okay. But we have only 3 equations. How many more equations do we need? We need 2 more equations. Where are they going to come from? Can you tell me? Where are they going to come from?
constraints.
Yes, constraints.
Work energy.
But what are the constraints? What are the constraints? क्या constraint? ये हम सब डिस्कस कर चुके हैं. This is nothing new. What is the constraint? What are the 2 constraints that you see here? भाई कंस्ट्रेंट मतलब एट द एंड ऑफ द डे यही होता है ना कि उसका मोशन किसी तरीके से हमने लिमिट करके रखा है. तो यहाँ पे इसका मोशन लिमिट कैसे हो रहा है?
x square plus
हाँ.
y square equal to
नहीं, मेरे को केवल कंस्ट्रेंट चाहिए और मुझे कुछ नहीं चाहिए. क्या कंस्ट्रेंट है इसके ऊपर? ये लैडर के
थीटा इज इक्वल टू वी बाय sin थीटा.
हाँ फिर से बोलो, नहीं सुनाई दिया.
Vx cos theta is equal to v by sin theta.
कैसे बोल रहा है? धीरे धीरे, मुझे नहीं सुनाई दे रहा है.
Sir, Vx cos theta is equal to v by sin theta.
ओह नहीं.
सर वो राइट में जो लिखा वही है.
हाँ सर.
हाँ. तो Vx और Vy का रिलेशन है ना. मेरे को तो Ax और Ay चाहिए ना. एक्सेलरेशन का क्या कंस्ट्रेंट है यहाँ? जब एक ऑब्जेक्ट रोल कर रहा है तो यहाँ पे क्या कंस्ट्रेंट है इसका? ये v से ऐसे जा रहा है या ऐसे जा रहा है, नो स्लिपिंग है. क्या कंस्ट्रेंट है इसका? व्हाट इज द कंस्ट्रेंट?
r alpha.
यहाँ पॉइंट की वेलोसिटी और यहाँ पॉइंट की वेलोसिटी सेम होनी चाहिए, राइट? दिस इज व्हाट वी डिस्कस्ड. यही तो होता है ना कंस्ट्रेंट यहाँ पे.
Yes.
Yes.
The object is constrained to move because of the presence of this horizontal surface. So what is the constraint here for the ladder? कहाँ पे उसका
x axis पे और y axis पे मतलब
ग्राउंड और वॉल से सरफेस
एक्सेलरेशन सेम है
हाँ.
पॉइंट ऑफ.
जो सरफेसेस हैं, जो 2 सरफेसेस हैं, वो उसके मोशन को लिमिट कर दे रहे हैं. Now we need once you have understood this fact by looking at the problem, that look, the horizontal and vertical surfaces are forcing the object to move in a certain manner, right? They are limiting the free motion of the ladder. Then the next step and this is true for all questions, okay? I'm generalizing, I'm being as general as possible so that you follow this in every question. So now the next question is, what is the constraint of this point on the ladder? What is the constraint of the bottom of the ladder? What is the possible acceleration of the bottom of the ladder? How is the bottom of the ladder bound to move? How the bottom of the ladder cannot move? नहीं आ रहा है. Very good, Anil.
Sir,
Yes.
AX equal to R alpha, L/2 alpha.
नहीं 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 नहीं, आप ओवर रीच कर रहे हो, फ्रिक्शन है नहीं प्रतीक्षा। बॉटम ऑफ द लैडर क्या नहीं कर सकता, किधर नहीं जा सकता है, मैं ये पूछ रहा हूँ। एज द लैडर स्लाइड्स डाउन
ऊपर
इट इज गारंटीड। हाँ तरुण, दैट इज द करेक्ट आंसर, यस। So it is guaranteed that the bottom of the ladder will move horizontally. Okay. Because of the presence of the horizontal floor, it is guaranteed that the bottom of the ladder will have a horizontal acceleration. Whether it is to the left or to the right, I don't know. Well, in this case, I do know it will be towards the right because there are no other forces acting on it. लेकिन अगर कोई और फोर्स एक्ट कर रही होती उस पे, तो मे बी इट वाज पॉसिबल दैट इट वुड हैव एन एक्सेलरेशन टुवर्ड्स द लेफ्ट, बट इन आइदर केस द एक्सेलरेशन ऑफ द बॉटम ऑफ द लैडर हैज टू बी horizontal. And what can you tell me about the top of the ladder? What is the foundation on the motion of the top of the ladder?
Vertical acceleration.
Vertical.
It has to, yeah, it has to have vertical acceleration as long as it is not leaving contact, and it is not
सर
leaving
बट वो
contact.
एक पॉइंट पे तो हो जाएगा ना।
हाँ, लेकिन हमने तो n लिया हुआ है ना, we have already written n is equal to max ना, हमने
Okay.
n को 0 तो किया नहीं है. So vertical acceleration for the top point of the ladder and horizontal acceleration for the bottom of the ladder, this is the constraint. And now we figure out what the acceleration of the bottom of the ladder is, right? And we use that theorem that we talked about, that the motion of the ladder is really a combination of translation of center of mass and rotation about center of mass. Therefore, the bottom of the ladder must have acceleration ax and ay, just like the center of mass. However, the ladder also has an angular acceleration alpha, like so. Therefore, the bottom of the ladder must have an acceleration alpha L/2, like this. क्या आया समझ में जो मैंने किया है यहाँ पे? I
Yes,
hope this is absolutely
Yes,
and clearly understood. जो सेंटर ऑफ मास का एक्सप्रेशन होएगा वो हर पॉइंट का एक्सेलरेशन होएगा, तो बॉटम का भी होना चाहिए. और रोटेशन की वजह से the acceleration should be alpha multiplied by the distance from the center of mass, and the direction of this acceleration must be perpendicular to the line drawn from the center to the point of which you have found the acceleration, right? So basically this angle is 90 degrees. Now we are saying that, look, for the bottom of the ladder, only horizontal acceleration is possible. Okay. This means that the vertical acceleration must be 0. Okay. And if the vertical acceleration has to be 0, then the component of alpha, because remember the net acceleration of this point, bottom of the ladder, is the vector sum of the blue arrow and the two yellow arrows. Okay. So the vertical component, अगर उसको 0 होना है, तो vertical component of alpha L/2 must match the yellow arrow which is drawn along the negative y axis. So this is 90 minus theta, this is theta. So I will get AY is equal to alpha L/2 into cosine theta. I hope this is understood by all. We are now going beyond the constraint conditions that we were looking at for rolling objects, because for rolling objects, the constraints always involved acceleration due to translation and rotation in one direction. तो a minus r alpha करना था या r alpha minus a करना था, right? लेकिन यहाँ पे जो constraint की condition है, that is telling us that the acceleration should be 0 in a particular direction. So we have to find the vector sum of acceleration due to translation and acceleration due to rotation in the vertical direction and equate it to in that particular direction, which in this case is vertical, and equate it to 0. Can you tell me the constraint at the top then?
Sir, Ax equal to alpha L by 2 sin theta.
Top only has vertical acceleration. इसका क्या मतलब हुआ? What is the meaning of this? तो इसका ax ay तो है ही है, यहाँ पे ax ay तो है ही है, वो तो होना ही है, लेकिन ये अल्फा की वजह से L by 2 alpha like this, and now the horizontal component must be 0. Therefore, we get ax is equal to alpha L by 2 sin theta. Okay, so now what I want you to do is I want you to use these 5 equations, okay, and solve them in the minimum possible time. Okay, this is the key now. ये physics अब खत्म हो गया यहाँ पे. Minimum possible time में please tell me the value of n, and this value of n should only come in terms of theta. Okay, maybe m आएगा उसमें, but m सारे terms में आना चाहिए, because ultimately we are going to put it to 0, and मेरे को theta की कोई value मिलनी चाहिए. In the shortest possible time, solve these 5 equations to get an expression for n, which involves only m, l, theta. M and L should be common, sort of. I don't think बड़ा answer आना चाहिए, because the answer is not really very complicated. We have to find out the value of ax. We have to find out the value of ax in terms of m, l, and theta. इन दोनों को अगर हम डिवाइड कर देंगे तो हमारे पास आएगा ay, which is going to be extremely weird. Ay is equal to cot theta ax, which is the same as this. Very, very weird. और उसके बाद से हम क्या करेंगे कि n1 की जगह लिखेंगे नहीं हाँ n1 की जगह लिखेंगे MAY, which is MAX cot theta. Oops. n1 की जगह लिखेंगे MG minus MAX cot theta. Okay. Whole into L cosine theta minus MAX sine theta into L is equal to ML square by 6, मैंने by 2 काट दी already, into alpha, right, into alpha, which happens to be 2AX by L upon sine theta. Right, now let's see what we can cancel out. We can cancel out L, and then L goes away from everything, which is very, very nice. M goes away from everything, which is again very nice. And this cancels out with this. So basically I'm getting G cosine theta minus AX cot theta into cosine theta, which is AX sine theta minus AX sine theta, okay, is
Sir,
equal
cos
to,
sin होगा
हाँ कहाँ गलती करी?
सर cot into cos
cot theta cos theta क्या होता है? sin theta नहीं होता है क्या?
cos
उल्टा
square
ले
theta
लिया।
by sin theta.
cos
तो
sin
हाँ, this is an example of mistakes that you should not commit. Cos square theta by sin theta is equal to AX upon 3 sin theta. Right? Now, these two terms look promising to me because when I add them, I will get cosine square theta plus sine square theta. Please solve now and tell me the value of x. X की value क्या आएगी? कुछ मीनिंगफुल आ रहा है कि नहीं आ रहा है? So, ये सबके अलग अलग आंसर क्यों आ रहे हैं? हाँ नहीं, वो तो समझ गया था। G sin 2 theta by 8. हाँ राइट, सो एवरीबडी इज गेटिंग, ठीक है, उसको थोड़ा सा और अच्छे से लिख दिया ना, ठीक है. So I will write it here. AX is equal to 3/4G sine theta cos theta. Right? Now there is a problem, and the problem is that if I were to calculate n, I could calculate very easily now. So since n is equal to max, this would simply be equal to 3/4 mg into sine theta cosine theta. Right? And the problem is that if I equate this to zero, I am not going to get anything meaningful. Okay. So this has told me, this thing has, what we have worked out the normal reaction on the rod on the ladder due to the vertical wall as a function of theta, right? But it is not telling us for some reason why. कहीं गलती तो नहीं करी, एक बार देख. Alpha एक सही. Okay. So now what I want to do is I want to use the work energy theorem on this just to make sure. And if the ladder slides from near vertical position to this, right, then the center of mass of the ladder, which was at a height of L/2, has now come down to a height of L/2 sine theta, if this angle is theta. This tells me that plus mg L/2 1 minus sine theta is equal to half m Vx square plus Vy square plus half ml square by 12 into omega square, where Vx and Vy in this case are the velocities of the x and y components of the velocity of center of mass, and omega, of course, is the angular velocity. So once again, we see that this point must have a velocity Vx, and Vy must also have an angular velocity of omega L by 2. So absolutely the same as before. We are applying the same set of constraints. So since the bottom of ladder moves along the x-axis, okay, we have Vy is equal to omega L by 2 cosine theta, and since the top of the ladder moves along y-axis, we get Vx is equal to omega L by 2 sine theta. Okay. Now I want to work out the value of Vx. So what I will do is I will write down mgl by 2 into 1 minus sine theta is equal to half m Vx square plus Vy square, right? And if I divide, or I really don't have to divide, we have already derived a relationship between Vx and Vy here. So I will get Vy is equal to cot theta Vx. So half m Vx square plus Vx square cot square theta plus half ml square by 12 into omega square, and omega square I can write as 4 Vx square divided by sine square theta into L square. Okay, so let's work this out again. क्या क्या चीजें कैंसिल हो जा रही हैं इसमें? ये कैंसिल हो जाएगा, L square 2 6 3 2 2 m m Am I right? कहीं गलती तो नहीं करी है? I think I am. Okay now. So I'll get GL into 1 minus sine theta is equal to Vx square into 1 plus cot square theta. 1 plus cot square theta कुछ होता है क्या? 1 plus cot square theta.
सर cosec square
हाँ,
theta.
sec.
थीटा
Cos square x होता है.
सर
cosec
cosec
square
square.
x y by
Cosec
sin square x.
Cosec square. Cosec square theta plus यहाँ पे भी आएगा cosec square theta by 3. Okay, so I get 4 by 3 cosec square theta Vx is equal to GL into 1 minus sine theta. So Vx is equal to under root of 3 by 4 exponential 1 minus sine theta into sine square. Is this correct?
Yes, sir.
Yes.
Okay. Now what I will do is, okay, I'm changing the slide. Now what I'll do is, I will say that look, contact is lost when Vx is maximum, because जैसे जैसे ये लैडर स्लाइड डाउन करता जा रहा है और उसके ऊपर ये नॉर्मल रिएक्शन एक्स डायरेक्शन में लगा हुआ है, राइट, whether this itself is decreasing or increasing is immaterial. The fact is that there is a normal reaction and therefore there is an AX and therefore Vx is increasing. But the moment we have the ladder losing contact, Vx will not increase anymore. So can you find the maximum value of this? You don't really have to find the maximum value of this particular thing under root mein. You can simply say that you want to find the maximum value of 1 minus sine theta into sine square theta. Sine square theta minus sine cubed theta. वे 2 कैसे आएगा तरुण यार, क्या बोल रहा है? मतलब बहुत ही फेमिलियर आंसर आना चाहिए भाई. है मैक्स वैल्यू ऑफ फंक्शन मुझे नहीं चाहिए, मुझे थीटा चाहिए जहाँ पे.
Sir, 3 pi by 2.
3 पाई बाई 2 कहाँ से आ रहा है यार? हाँ, ये आना चाहिए. जैसा आएगा ना, या मैं भी डिफरेंशिएशन भूल गया हूँ क्या? मेरे ख्याल से तो सही है.
सर लेकिन साइन थीटा को -1 डाला तो
हाँ, माइनस माइनस कहाँ से आ रहा है?
सर अगर sin थीटा को -1 डाला तो फंक्शन की वैल्यू 2 हो रही है. मैक्स वैल्यू है वो उसकी.
साइन थीटा को -1 डालना क्या कर रहा है? मेरे को साइन स्क्वायर थीटा माइनस साइन क्यूब थीटा का वो चाहिए. 2/3 डाल के देख क्या होता है. देख मेरे ख्याल से लोकल और ग्लोबल मैक्सिमा का फंडा हो गया। मेरे को लोकल मैक्सिमा चाहिए।
सर नेगेटिव का कोई मतलब भी नहीं है ना, क्योंकि नेगेटिव जा नहीं सकता थीटा।
हाँ वही फिजिकली इम्पॉसिबल।
पॉजिटिव में 2/3 है सर।
हाँ
पॉजिटिव में साइन थीटा 2/3 है सर।
हाँ this is the angle at which contact will be lost. Let me try one more method before we.
सर वो नॉर्मल वाले में प्रॉब्लम क्या हो रही थी?
हाँ नॉर्मल वाले में we are not let me just do it once again. एक बार और करते हैं। So if we take the instantaneous axis of rotation, then इस axis के about केवल रोटेशन हो रहा है। So we will have perpendicular distance. Torque will be equal to mg into L/2 cosine theta. This will be equal to ml square by 12 plus ये कितनी distance आएगी? What is this distance?
सर ये डिस्टेंस है कि कॉन्स्टेंटली चेंज होती रहेगी।
हाँ मैं तो उस मोमेंट इन टाइम पे निकाल रहा हूँ। क्या डिस्टेंस आएगी है थीटा के टर्म्स
स्क्वायर
में?
माइनस L/2 होल स्क्वायर।
हाँ
x स्क्वायर माइनस L/2 होल स्क्वायर,
x क्या है?
मतलब x
आपने
कोऑर्डिनेट।
पिछले फिगर में लिया था।
x क्या है? मेरे को नहीं समझ में आया।
सर x कोऑर्डिनेट मतलब लोएस्ट पॉइंट का x कोऑर्डिनेट क्या है?
L cos थीटा है और क्या है?
सर
हाँ
L/2
सर वही मतलब।
कितना आएगा? L/2 tan थीटा।
सर खाली L/2 है सर।
खाली L/2 आएगा।
सर क्योंकि रेक्टेंगल बन रहा है और ये सेंटर है तो रेक्टेंगल के डायगोनल्स सेंटर से तो डिस्टेंट होता है ना, मतलब
तो
सारे
रेक्टेंगल
पॉइंट्स।
रेक्टेंगल तो L cos थीटा और L sin थीटा है ना।
हाँ सर बट ये जो डायगोनल्स है उनका डिस्टेंस तो उनका लेंथ तो सेम होता है ना डायगोनल्स का।
डायगोनल्स का लेंथ सेम होएगा, इससे उससे क्या लेना देना मेरे को?
सर सही बोल रहे हो।
सर L/2 ही होगा।
L/2
अगर आप
L/2
ऐसे
ही आएगा।
देखेंगे तो L/2 sin थीटा होल स्क्वायर प्लस
सर
L/2
अगर आपने
cos थीटा
कोऑर्डिनेट लेके भी
L/2 आएगा ना फिलहाल।
हाँ सर।
हाँ सर।
हाँ सर।
So I will get mg L/2 cosine theta is equal to ये कितना आएगा? 1/12 plus 1/4. 1/12 plus 1/4. 4/12.
1/3
1/3. ml square by 3 into alpha. So alpha is equal to 3g cos theta by 12. Okay. So ax, which was equal to how much, which we had already figured out,
L/2
ये रहा ना ax, alpha L/2 sin theta.
और
तो ये आएगा 3g cos theta by 12 into L/2 into sin theta. is equal to 3/4g cosine theta sin theta. Is this the same answer that we got?
हाँ सर वही है.
वही है ना? हाँ. तो ये इंस्टेंटेनियस एक्सिस ऑफ रोटेशन से इमीडिएटली आएगा. अब यहां से वो कैसे निकालेंगे थीटा जिसपे वो how do you do that? Cos theta sin theta. So we have got here n1 हमें मिल गया, n मिल गया, सब कुछ मिल गया. ये कंडीशन मुझे चाहिए ना, क्या कंडीशन आएगी? Acceleration of center of mass is 0. N is equal to n is equal to 3/4 mg sin theta cos theta. So how do I don't think I can get this. फिलहाल दिमाग में नहीं आ रहा है मेरे. बट ये वाला वर्क एनर्जी वाला समझ में आ गया ना कैसे मैंने किया है. मैंने Vx निकाला और उसको मैक्सिमाइज कर दिया.
सर तो जो ये वाला मेथड है उसके लिए इससे पहले जो भी किया था वो तो यूज का नहीं हुआ ना, AX वाला पूरा पार्ट.
नहीं होता है बट मेरे को याद नहीं आ रहा है कैसे. बट अपेरेंटली एज इट इज बिल्कुल यूज नहीं. या एज इट इज उसका यूज नहीं दिखाई दे रहा है.
सर ऐसा तो नहीं कि कोई कंस्ट्रेंट गलत लिख दिया हमने.
Correct. As long as the object is in contact, this is the normal reaction with the vertical wall of the ladder. And since we know n, we can work out n dash, we can work out ax, we can work out ay, we can work out everything. अभी आएगा दिमाग में आएगा. अभी छोड़ो, अभी बताता हूँ मैं. Okay. So now that you have seen the instantaneous axis of rotation wala thing, you can use it, you are free to use it, but थोड़ा सा डाइसी कभी-कभी हो जाता है. I would prefer that you use this method as compared to instantaneous axis of rotation. However, it is definitely much more faster, right? यहाँ पे हमने ट्रांसलेशन के लिए इक्वेशन लिखा, रोटेशन लिखा, उसके बाद से हमने कंस्ट्रेंट के इक्वेशन लिखे. लेकिन इंस्टेंटेनियस एक्सिस ऑफ रोटेशन में हमें एक बार टॉर्क लिखना पड़ा और कंस्ट्रेंट के इक्वेशन लिखने पड़े बस.
सर फिगर आउट कैसे करेंगे कि ये वो वाला क्वेश्चन इंस्टेंटेनियस एक्सेस वाला?
चलो मैं थंब रूल बता दे रहा हूँ. अगर जो किसी प्रॉब्लम में आपको इंस्टेंटेनियस एक्सिस ऑफ रोटेशन दिखाई दे रहा है, राइट, यू कैन यूज इट, नो प्रॉब्लम. That is the, I mean, for the sake of speed, uh, you can use instantaneous axis of rotation. प्रॉब्लम इसमें केवल एक आती है जो हम इस चैप्टर के एंड में डिस्कस करेंगे ही, और वो है जब भी हम कोई ऐसा एक्सिस लेते हैं, जब भी हम कोई ओरिजिन टॉर्क निकालने के लिए ऐसा ओरिजिन लेते हैं जो सेंटर ऑफ मास पे नहीं लाई करता है, the only problem that comes into being is that if there are pseudo forces acting on the system, then these pseudo forces will also generate torque. Now, if you're taking the center of mass as the origin, then that will never happen, because pseudo forces will also always pass through the center of mass. They act through the center of mass. Therefore, the torque by these pseudo forces about the center of mass will always be zero. It's like mg. But if you are taking an external origin, if you are taking a different origin as compared to the center of mass, right, then you have to be careful about pseudo forces. Instantaneous axis of rotation में generally pseudo forces, they don't make an appearance, but sometimes they may. कब यूज करना है? जब आपको मालूम है कि pseudo force नहीं है. नहीं करना है तो आपको मालूम है कि pseudo forces आएंगे. Okay, so using this concept of constraints that we have discussed, here is a simple problem. So a rectangular plate of mass m is suspended from ceiling as shown. Find ACUM. Find ACUM just after the right string Sorry, मेरा connection is very poor. I'll just rewrite the question. हाँ, या ऐसा करो, सुनो, मेरा कनेक्शन और गड़बड़ होएगा. You do this question, okay? Find ACUM just after right string is cut. Okay, I'll give you the hints. Number one, what is the motion after string is cut? Okay. Number two, what are the constraints? Very good, Pratiksha, yes. What are the constraints after string is cut? Can anybody tell me the constraints after the string is cut? Very good,
Sir,
yes.
t equal to 0 हो गया तो
नहीं, कंस्ट्रेंट जो एग्जिस्ट करता है वो यहाँ एग्जिस्ट कर रहा है. क्या कंस्ट्रेंट है इस पॉइंट का?
सर
आफ्टर द
acceleration
राइट
of
स्ट्रिंग.
ceiling और वो सेम
Exactly. किधर? Be very careful with this statement now, because we are now at the next level of complication. Acceleration of this point and this point must be same, but where? In which direction? Can this point have horizontal acceleration? Can this point have vertical acceleration? Can this point have any acceleration? What is the constraint?
सर vertical
वर्टिकल होएगा या नहीं होएगा?
मतलब सेम रहेगा. हाँ.
हाँ, very good, yes. So along the string the acceleration must be same. Net zero नहीं होएगा प्रतीक्षा. Not net. Okay. So the constraint is, if this is point P, then vertical acceleration of point P is equal to 0. हाँ, बिल्कुल सर. Yes. अच्छा, हाँ, okay, हाँ, I understand what you mean. Yes, absolutely right. That is exactly what I wanted to say. Yes. Okay. And I'll give you two more questions. Same questions. Okay, same question, but this time this is a hinged support. तो ये वाले क्वेश्चन में दो स्ट्रिंग से लटकाया हुआ है, ये वाले क्वेश्चन में दो हिंज्ड सपोर्ट से लटकाया हुआ है. राइट सपोर्ट कट हो जाएगा. Then what will be the acceleration of center of mass? और तीसरे वाले में दो स्प्रिंग से लटकाया हुआ है और ये राइट वाला स्प्रिंग कट हो जाएगा. ये के है, इनका स्प्रिंग कांस्टेंट. In all the three cases, the right support is cut, and you have to find the acceleration of the center of mass just after the right support is cut. Okay? ठीक है ना? चलो, so do these questions. Take a screenshot. We'll meet in the next class. So this chapter is almost over now. One more thing remains, that is the angular momentum and the collisions वाला part. And उसके बाद से we'll discuss in 1 or 2 classes ये जो slipping होती है, जो axis away from the center of mass ले लेते हैं, 2-dimensional 3-dimensional rotation जो हो जाता है, that we'll discuss. Toppling, yes, toppling, yes. Slipping and toppling actually एक साथ ही होता है. चलो, okay, so I'll leave you. Please send me the solution to this on WhatsApp.